Hello, everyone. Good evening. Welcome to your favorite moment of the week, the Monday evening session, review session of business analytics.
Totally, Jerry.
Hi, Morgan.
Jerry, is the evaluation still open?
Oh, yeah. Thank you for reminding. Yes.
Would you mind sending us the link again? Because I have a little bit more time today and tomorrow, and I really like to send
Sounds
that.
good. Yeah, sure. You will be able to find the link in the announcements. One of the announcements was sent by me, and it includes a link. Yeah, so for other students who did not have a chance to fill out the feedback for my review session, you could also do the same thing. You can also find a link conveniently on our shared review session notes. It's exactly the first item on top of the document.
Perfect.
Well,
thank you so much.
No problem. All right, so I also appreciate it if you fill out the feedback for me. Any questions? How was the past week and the weekend for you? Did you find any part challenging for the new week content that's mostly about hypothesis testing?
Would you go over the homeworks and kind of elaborate on the concepts? Because this homework was right after a big, heavy test, and it was a really long module.
Oh, okay.
Yeah, and I think I'd like to kind of learn more. A lot of it is just plugging numbers into the spreadsheet, but I think it would be really nice to know why we're doing the way we're doing things and how to interpret the numbers. I really appreciate if we can get that overview.
Okay, sure. I can definitely do that. I also believe Professor Apple's videos and in-person sessions will also address some of the content, if not all, already. But let's take a look together. First, let me share the homework questions so we know what's being practiced this week. Okay, this one. All right, first I encourage you to pull up your document of report and also Excel file so that you can see whether your approach is any different than what we practice and demonstrate here. So in this week, we talk about hypothesis testing. This is closely related to confidence intervals we did last week. In fact, they are quite equivalent in many cases. For example, if we are testing whether a coefficient is, is significant at 0.05 significance level, it's equivalent as if asking whether the 95% confidence interval includes 0 in it. So what we learned this week is instead of a completely new thing, it's a complement to what we have learned previously. All right. With that knowledge, we should feel more comfortable addressing these problems. In problem 1, we assess some stock issues, I guess. Okay, we have 60 minutes about delivery zone. No, this is about the delivery time. So we are testing some distribution of the delivery time. So first, we assume a random sample of 50 deliveries. And we measured these 50 deliveries of Amazon and found that the average delivery time was slightly larger than half an hour, and there's a standard deviation of 5.4 minutes. Then our question would be to test whether the sample provides sufficient evidence against claim that the 5% level of significance. Notice that this claim is that, okay, this claim would be this 60 minutes that the company plans to develop a delivery drone that would cut delivery time for products purchased on Amazon to an average of 30 minutes or less, right? So the claim was that the average delivery time was half an hour or less. And we collect a sample and test whether we should reject this claim or not. And we also need to calculate a p-value and explain how we interpret it. And then we will use the same data to perform another test at a 1% level of significance. Okay, has any of you tried to address this problem, and what have you found so far?
Quick question, Jerry. This is Adam speaking. So the null hypothesis in this case would be going against the claim, meaning that it's going to take more than 30 minutes to deliver. This is what the null hypothesis would be.
Unfortunately, usually we form the null hypothesis exactly on the opposite. So that's a very important question. Because all hypothesis testing should begin with establishing the null and alternative hypothesis as exactly laid out in my notes. So as oh, I see. Well, I have to sign in before I can make any. I guess I'm signed in now. Okay, before I can make any edits to the document. Okay, I guess it's best if I change the order so that this part is. I see. Oh my God, I would have to do this. So no, the about null hypothesis, it's usually formed in a way that we do not find a difference or change or any effect. So in this example, that means if our claim is that the original or the ideal distribution or the delivery time mean value is less than 30 minutes, right? So we should definitely use that as the null hypothesis. We can practice this a few times in problem 2 and 3, so you can see clearly how it's a null hypothesis can be conveniently determined simply from the question. Oh, was there a question?
Hey, Jerry, it's Tony. Can you hear me?
Yes, I can.
I noticed in the video from Thomas, he said that the null hypothesis always has to have an equal sign. That kind of stumped me because I wanted to say, you know,
oh, I see.
It's less than 30, but in this case, you have to put an equal sign there. How do you do that?
The answer is the particular context when the professor said that we usually put an equal sign in terms of the null hypothesis is that when we test whether a coefficient or some mean value is equal to something. But in other occasions, in our problem, for example, it's not equal sign. So what's being said was basically the null hypothesis, it is the opposite to the alternative hypothesis. So these two parts should form against each other. So there's no other third option at all. So for example, in our case, we would do that. We would use H0 as null hypothesis and would claim that mu would be less or equal to 30 because that's the that's what the original claim was. However, we should not use the original claim as the golden rule as determining the null hypothesis. Instead, here notice that we are finding evidence against something, right? So what's behind this against would be used as the null hypothesis. And it just happens that in our case, it's the CEO's claim that's what we are finding evidence against. That's why we are using that as the null hypothesis. So with that being said, what would be the alternative hypothesis if I have mu smaller or equal to 30 as the null hypothesis? Any answers?
Greater than 30?
Yes, perfect. As we discussed just now, the alternative hypothesis will be exactly the opposite as the null hypothesis, so that they should form all possible options. And because this mu, the average delivery time, if it's not less or equal to 30, it must be above 30. So we would have this mu1 as greater than 30. Any questions here? All right, now we learned how to form null and alternative hypothesis. We should also discover some related statistics from the question. First, what would be the significance level? We found in the question that in part A, it's 0.05, in part B, it's 0.01. These are very conventionally used two levels of significance. However, in some published articles, you will find some even, one other commonly used significance level that's 0.001. That's like 1 over 1,000. So that means if the null hypothesis would be, first, let's review the concept of the significance level, why we are using these somewhat arbitrary numbers as the threshold. Once we understand the logic of hypothesis testing, we will find that the significance level is nothing but the assumed scenario if the null hypothesis is true. So in our case, it'll be if the original claim was true, so that the delivery time on average would be less than 30 minutes. Then we would observe that only 1 out of 1,000 chance that a randomly selected sample of this large, that'll be 50 deliveries, would go higher than 32.1 minutes. So it would be a very extremely likely case. It'll be the same as 0.01 and 0.05, representatively, respectively. They mean that only 1 out of 100 or 1 out of 20 samples, if we sample the population under the null hypothesis repeatedly many times. So each time we take 50 deliveries, and second time we also take 50 deliveries. We take 1,000 times of such samples, or 100 or 20. Then we expect that 1 out of these cases would show that the mean value of delivery in the sample is this much or greater. That's what these significance levels stand for. Any questions here?
Sure, I had a question, and that makes sense. Thank you. So are we saying here the population mean is 30 because that's the claim? That's where I was hung up.
Yeah. Oh, okay. So you're right that when we do null hypothesis testing, it's always to test about the unobserved population parameter. Because if we already measure the sample. There's nothing more we don't know about the sample, right? So we don't ever need to test anything about the sample. However, in contrast, we want to infer something about the population out of a sample. That's why we're doing hypothesis testing. Out of this 50 deliveries, we are trying to understand what the population, that means all possible delivery made by Amazon, would follow certain distribution. And this distribution, in our case, is described solely by the mean value. So we are concerned about the mean value only. That's why we are testing about the mean value, about the population that's not directly observed, but we sampled a sample to understand it. Did I address your question?
I think so. So, I mean,
Okay.
unfortunately, like Sherway said, we're kind of playing catch up because it was a long weekend. But when I was looking at the template, I used sigma unknown, and I use the population mean of 30, and then I use the sample mean of 32.1 because I think in the logic that's the claim is 30.
Oh,
And
okay, I see. Well, I will have to go into the sheet to see whether the procedure you described is correct, but it sounds correct so far.
It was a lucky guess, I think.
Okay, yes, I see. So although in the sheet, it might be described as there's a sample mean, there's a population mean, that we are going to test the difference between them. But while doing so, we need to understand that in any type of hypothesis testing, we are testing about the population, which is an observed. Otherwise, if we already know the average delivery time is 32.1 in the sample, there will be questions like, oh, why we're even going to test about it? The answer is what we are testing is not about the sample, but we are trying to infer the underlying population behind or beneath this sample, where the sample was drawn from. All right, was there another question? Hi.
Jared, yeah, this is Mark here. So I think we have to use critical values. Because I was talking with Thomas and we was the Professor Epple and we talked about critical values. N minus 1 is 49. And I think that changes it just a little bit. So what I did, I went into the critical values and put in 49 and minus 1, 50 minus 1, 49. And then that seemed to bring it over to the actual sheet for the hypothesis testing.
Okay, yeah, sounds good to me. I think your question lies in that whether we should use 50 or 49 as the degree of freedom, was it?
Basically, yes.
Oh, okay. All right, that's also a very good question. The degree of freedom should be 49 in this case, because we do not know the sigma, that's the population variance or population standard deviation. Okay, let me pull out the Excel file for the hypothesis testing tab, so that we can see what parameters and values we should fill in. But before then, let's review that once we understand the null and alternative hypothesis, and we understand what the significance level should be used as input, and we should also find some known values from the question, such as the sample mean, sample deviation, and something about the reference population parameter, like the reference here would be 30. Then we need to calculate some critical value. For example, in this case, we are going to calculate a t-value because we do not know the population standard deviation. And we form a test statistic, that's the t-value, and we compare it with a critical t-value. And what the last student mentioned was it matters when we calculate this t-value, because to do this t-value, we would need to find the degree of freedom so that we can compare it to the correct critical t. Then after that, we make a decision and we find the implication. And it's very important that all of these procedures must be step-by-step followed so that we understand what hypothesis we're testing and what logic we follow to resolve this problem. All right, with that understood, let's put that into practice.
Gary,
Okay.
Gary, it's Tanya. I have a quick question.
Tanya.
Hi, how are you? Professor Epple or Thomas was telling us that if we use the hypothesis test tab and we do the hypothesis sigma unknown, that it automatically calculates the t distribution for us. Is that correct?
I believe so.
Okay,
because this sigma unknown exactly means that we would use a t-value in this case.
okay, great. So
we can easily find that also. For example, if we look here on my shared screen, the test statistic is marked as t. In contrast, in the sigma known case, the test statistic is marked as z. That's why we know that it's also safer to say that what's followed here is a t-value. And we can also tell by going to the critical value case, we find that this is calculated as the inverse distribution of the t. So that's why we know for sure that this is what's calculated as critical value is a t-value.
oh, perfect. Thank you.
All right. I noticed that there are some build-up in the chat area. Is there any important thing before I go into the practice? Okay, it was a discussion about degree of freedom. All right, let's put that into practice. We know about the... Oh, okay, I see. Let me make sure this is what I expected to work. Yes, all right. So in this case, we would put 30 as the reference population mean here. Notice that we do not have any further knowledge about the reference values. That's why we only have 30 here. Significance level, by default, it was 0.05. So we don't have to change it. The sample size, the sample mean was 32.1, right? That's what I recall. And the standard deviation was, could you tell me? Okay, 5.4. 5.4, and the sample size was 50. As you can see, there are 3 tabs formed. Which of these did you use to draw some conclusions?
Right-tailed one.
Left tail.
Okay, you used the right tail one.
Right tail.
Any questions here? Any different answers?
Is it right tail?
Yes, we could tell that by how the null hypothesis is formed, because all the others is, as you can see, is simply opposite in sign. The critical value is opposite in sign, but other things like the test statistic is exactly the same as any of these 3 cases, but they are very different in p-values. In particular, you notice that these p-values from the left to right tail, they add sum to 1. So if you follow the left tail while the correct answer should be the right tail, you find exactly the complement of the correct p-value, whereas the correct answer would be to reject the null hypothesis. The wrong answer would be to not reject the null hypothesis. So the answer would be quite different. And how do we judge which of these three columns to use? This should be a comparison about how the null and alternative hypothesis is matched with our established one. Recall that we just now claimed that the null hypothesis would be mu smaller or equal to 30, whereas well, the the alternative hypothesis, or HA or H1, is mu greater than 30. That's why we find the same thing as it shows here. It aligns with what we established as the hypotheses. Otherwise, you find that the null and alternative hypotheses and the left-tailed would be the opposite. So that's why we don't take that. All right. Here we could also find how this t-value is calculated. Note that it's rounded. That's why you don't find the digits to be exact, that exact. But from this, we can understand that how this t-value is calculated. We notice that it's nothing but 2 times C28, which is the significance level. Because here we are doing the one-tailed hypothesis testing. So when we calculate the critical value, it's equivalent as calculating the critical value for a two-tailed test with double size of the critical of the significance level. And we find that the degree of freedom here is exactly sample size -1. That would be 49. So that's how the critical value is determined. Any questions here?
Oh yeah, the question about the p-value, if I'm not rushing you, Jerry, is that so the p-value is really close to nothing, and that means we're more confident, right? The lower it is, the more confident we are.
More confident. Let's see. I haven't seen such interpretation before, but the lower p-value, the lower chance that we make type 1 error. That means that this underlying distribution that we're testing, that's the true population mean of the delivery time, would be different than 30. Well, so once we understand the critical value, then we can also find how this t statistic is determined. As we can see, it's nothing but a ratio. What's going into the denominator is the difference between the sample mean, or the underlying population mean behind the sample, and the reference population mean, so that each of them represents the null and alternative hypothesis. Then what's going into the denominator is what we have learned already last week. That's the standard error. And we calculate the standard error as the standard deviation of the original values. It's not, that's how it transforms the standard deviation about the original value to a standard deviation about the mean value. Then after it's divided by square root of sample size, so that the denominator is just the standard error that represents the standard deviation or the variability about the population. A population mean, excuse me. All right. Now we also find test statistic. Hello, was there a question?
Yes, to Stephen's point, is it safe to say that if the p-value is less than the significance level, then it is significant?
Yes, exactly. That's how this p-value is used.
So in this case, it will be less than, since the p-value is less than 0.05, then the result is significant.
Yeah, you're right.
Thank you.
That's what we
Jerry?
do exactly in the next step.
Hey,
Hi.
Jerry, thank you. In addition to what Adam stated, could you also state that the p-value is independent from the significance level? Therefore, changing the significance level doesn't directly change the p-value. Would that be correct as well?
Yeah, you're right. We determine the significance level before calculating the p-value.
Right, but if you change the significance level, at least in this case, it doesn't
It
change.
won't. Yeah. So for example, let's just do a, you notice that only the critical value is changed, but the p-value is not. So when we compare these two values, as you described, the significance level is a predetermined threshold. That's why it has nothing to do with other values. That's also how we can assess that it's, independent from other things.
Okay, thank you.
But for whatever reason, if, and only if, hypothetically, the p-value, just in this case, when the significance level is 0.01, if the p-value, let's say, is 0.05, then it's not significant, correct?
Oh, I see. What you're asking is like a border situation.
Yeah, a hypothetical situation where the significance level is 0.01, yet the p-value came out. I don't know how it would come out. It would be, for example, 0.05.
So numerically, you don't see that because when calculating this p-value, let's see.
So how can I say that this is not significant?
Unless you're intentionally built up the sample mean to be what's required to get a p-value that's exactly 0.05, then you won't see that. So in my practice, I've never seen that the p-value exactly lying on the border. So we make a well, let's see. If that ever happens, we simply make a determination in the beginning saying that this p-value is smaller than the significance level, then we would claim significance. Then it's done.
Right, but if the significance level is 0.01 and the p-value came out, forget about the 5. Let's say 0.06 or 0.04 even. Then it's not significant, correct?
No, it's not. So for example, in our case, if I change the critical significance level to be this 0.001, it's also a very commonly used significance level. That's 1 out of 1,000. Then in this case, we would claim that as you can see here, well, this decision part is already that we don't reject H0. But recall what's H0, that's the null hypothesis. We don't reject the hypothesis that the mean value is smaller than 30 minutes. So in this case, it would mean that we don't have significance evidence to reject the claim made by the CEO. So with that, we actually practiced all parts of the null hypothesis testing. Note that we first state both hypotheses and the significance level so that our audience understand what we are testing against. Then we calculate the critical value as we just did here. That's the critical value, T. And also we do that for the observed test statistic. That's a T statistic we just calculated as the ratio between the difference in mean value and the standard error. So as I noted here, it's usually calculated as a difference between two means and to be divided by the standard error. That'll be the standard deviation divided by square root of sample size. So with that, we compare. This comparison can be about the t-value. If the t observed statistic is greater in magnitude than the critical t-value, or this comparison can be done about the p-value, whether this p-value is smaller than the significance level. Then we determine, then we make a decision that we reject the null hypothesis. So as you can see here, because this test statistic under this specific changed significance level is smaller than the critical value. So we say that we determine that we don't reject H0, that's the null hypothesis. We would achieve the same conclusion if we compare the p-value with the significance level that I altered here. However, going back to the part A setting where the significance level is 1/20, we find that the observed t-test statistic 2.74 is greater than the critical value 1.67. That's why we determine that we reject the null hypothesis. Or we could find the same conclusion if we focus on p-value. So if we compare p, that's 4 out of 1,000, with this 5 out of 100, we find that this p-value is smaller than significance level. Then we determine that we also reject null hypothesis. Well, in the case that you ever find this p-value is on the border, you still use this smaller sign, smaller than sign. Then you compare whether the p-value is smaller than the significance level. You do the same for the t statistic. So if this test statistic is greater than the critical value, it doesn't include the equal to case, then we reject the null hypothesis.
That's great. Thank you.
All right. Then could one of you try to interpret what it means when we reject the null hypothesis? So in our part A question, we already find that we are going to reject the null hypothesis. So how are you going to interpret the case so that you can answer how it's related to the conclusion or interpretation part? Any volunteers?
It takes more time than 30 minutes to deliver using drones, since we reject null hypotheses.
Yes, that's a great answer. To interpret the hypothesis testing results, note that here the result is either to reject or we cannot reject the null hypothesis. In the case that we do reject the null hypothesis, given the evidence, we go back to the null hypothesis and alternative hypothesis. Because we rejected the null hypothesis, so that the alternative hypothesis is the remainder. That's what we need to take. And in this case, we would claim that because we reject the null hypothesis, the average delivery time is greater than 30 minutes. That's simple. So in the other case, if, for example, we change the significance level to be 0.001, we find that we do not reject the null hypothesis. Could another student try how you interpret this conclude or this decision? using some substantive or qualitative arguments.
Sorry, Jerry, it should be for the significance level, it's 0.001, not 0.01.
Okay, yeah, thank you for the clarification, but here we are just doing a practice. I'm not copying exactly what's written in the questions.
Oh,
So,
okay.
so Jerry, in this scenario, then we couldn't reject the null hypothesis, and we're in danger of committing a type 2 error. Is that correct?
No, first, it's not about type 2 error at all, because type 2 error is about power. And here we are doing significance. So significance is about type 1 error. That type 1 error means when we, given that there is no difference or no effect, and in our case, there's no evidence against the claim. That means the population mean is smaller than 30, right? That's what, then if in that case, we reject this hypothesis and claim that there's significant difference, then that's what it means by type 1 error. So let me try.
So in this case, it would take less than 30 minutes to deliver through drones.
Yeah, we would
If the
say,
p-value was correct.
Yeah, because here the p-value is greater than the significance level. At the same time, or equivalently, the test statistic of the t we calculated is smaller than the critical t-value. We don't reject the null hypothesis, right? Then the interpretation we could make in this case is that there is no significance evidence that the average delivery time is greater than 30 minutes. So that you could fill in the information about this test into the statements that we're going to make, so that everything is in context.
Could you repeat that one more time?
Yeah. So given this case, if I change the significance level to be so small that the p-value is greater than that, then I did not find a significant result. So the decision would be, don't reject the null hypothesis. We would build the interpretation saying that we did not find significant evidence against the null hypothesis, or we did not find significant evidence that the alternative hypothesis is in play. In this case, when we put that in context, we will say that at this significance level, that's 1 out of 1,000, we did not find significant evidence that the alternative, that the average delivery time is greater than 30 minutes. Or equivalently, you could also say that we did not find significant evidence against the hypothesis that the average delivery time is smaller than or equal to 30 minutes. So you could play these word games. All right, now we understand all procedures about null hypothesis testing. What are some questions you had about problem 2 and 3? They should be almost the same procedure.
So 2 seemed almost too easy. So we're literally testing if it's exactly 6 centimeters. It's kind of like the same question where we know the answer before we start, because we know it's not going to be 6.
Oh, I see. Let me see whether it's actually that simple. Maybe you're right. Okay. So it's about some homework assignment when we have okay, estimate the average length of bots. We have 80 bots in the sample. We know the average and the standard deviation about the sample. Now, we also know the confidence level. Confidence interval. Oh, okay. This actually goes back to what I said in the beginning, that about the equivalence between confidence interval and hypothesis testing. And as you noted, you took the smart way, that you did not recalculate everything, but used the information of the confidence interval to derive the decision in the hypothesis testing case. Did other students understand what I just said?
No, Jerry, can you explain it again?
Okay. So doing hypothesis testing and building confidence intervals are equivalent procedures. If we take the significance level as the remainder of the confidence level. So here, if we have a 95% confidence interval, it's as if saying that if we do a 5% significance level in hypothesis testing, we find some equivalent results. Let's see what this equivalent means. So let's go back to this case. Okay, let me see whether, okay. Require average length to be 6 centimeters. Use the same data, test whether the average bots meets these specifications. Okay, all right. Without understanding the relationship between confidence interval and hypothesis testing, let's just go ahead with hypothesis testing and see what it does. So if our population reference mean here is what we are testing against, that's the engineering standard, right? The average length would be 6 centimeters. And the sample was 6.2. And the standard deviation is 0.1, right? That's what I recall. Okay. And we have 80 bots as the sample size, and 95% as the
Confidence interval.
Confidence interval. So here we transform the the confidence interval to a significance level. That's why here it's announces as 5% significance level. Okay, we do that here. Then we find that what we are testing against, note that which of these 3 columns are you going to use in this case?
Hey, Jerry, your standard deviation should be 0.1.
Ah, thank you. Okay, now which of these columns are you going to use in this hypothesis testing?
I think the
We would
two-tailed.
Two-tailed test because we're looking for data between the upper and lower limits.
I think we're just looking for 6 on the nose.
You're also right. Yeah. Okay. So this comes from the question itself. Note here that what's being tested against is the statement that the average length of bots is equal, well, is 6 centimeters. It's the same as if saying the average length is equal to 6 centimeters. That's why we use the center column. Then we find that this center column tells us that we are going to reject the null hypothesis because the test statistic in magnitude is greater than the critical value. So that it's outside of this interval of -2 to +2, because the test statistic is almost 18. Then we also have the p-value that's very close to 0, so that it's smaller than the significance level. So we reject the null hypothesis. The null hypothesis here is that the average length is 6 centimeters. Then here, if we go back to the confidence interval, we find that this confidence interval is does not include 6 at all. That's what I mean that there's some equivalence or relationship between confidence interval and hypothesis testing. So here, the decision of rejecting the null hypothesis can be also made by the relationship between the confidence interval and the reference population mean. So we could also say that because the 95% confidence interval is this, which does not include 6 centimeter inside of the interval, right? So we reject the null hypothesis. And by rejecting it means that the average length of bolts is different from 6 centimeters. Any questions here?
Can we say we accept the alternative hypothesis instead of saying we don't accept the null hypothesis?
Let's see.
So that's how
I think so. We usually say that we reject or don't reject the null hypothesis. And we rarely use accept. So avoid using the word accept at all. Usually it is treated as a mistake if we accept the null hypothesis. Instead, if we accept the alternative hypothesis, I haven't seen that there's a strong statement that this is wrong, but it also sounds strange. Usually we don't see such statements.
I think it's because, or is it because once you accept it, it means you're embodying the type 1 error in your answer? Is that the case? Why we do not say accept? Because if you say accept, it means type 1 error might be included. Or actually, I take it back. You're saying you're excluding type 1 error, but if you say I do not reject or I fail to reject, it means that you're putting the type error as type 1 error in the answer, but not clearly.
Adam?
You're not stating it clearly.
Interesting thoughts. I haven't thought that way. However, I do not believe that either type 1 or type 2 errors or whatever type of errors are going away just because we frame the conclusion in a certain way. If we maintain the rest of hypothesis testing procedures the same, so those other errors would be there if we do this hypothesis testing. It won't go away just in the decision part that we frame the statement in a different way. My understanding is that comes from the fact that no significant difference does not mean statistical equivalence. So, for example, here in our it was already gone, right? So earlier we had the delivery time case, right? And if I use a more strict significance level that's smaller than what's written in the question, then it's possible that we derive a decision saying that we don't reject the null hypothesis. So here, this decision does not mean that the average is equal to 30. So we could only say that we do not have strong evidence against that the mean is smaller or equal to 30. We cannot build equivalence just so.
And that's why we use fail to reject instead of accept, right? Because if you say accept, it means you do accept it. But if you say fail to reject, it doesn't mean that you accept it. Failing
Yeah.
to reject is not equal to
So
acceptance.
statistical equivalence is usually built with additional information. So for example, if if the original question was whether the average delivery time is 30 minutes exactly, then we would use the middle column to answer this question, right? Because the null hypothesis in that case is the average delivery time is exactly 30 minutes. So in this case, if we follow up, then we find the decision is don't reject. We won't say that the mean value is 30, because if we did that, it would mean that there's some equivalence between the average mean delivery time and 30 minutes. We don't do that, then we avoid such mistakes, because to establish such equivalence, we would have to add some buffer zone. This buffer zone comes from usually what's currently often referred to as domain knowledge. Otherwise, it'll be called as expert knowledge. Anyway, this expert knowledge would give you a safe buffer zone about what degree of difference we can accept before rejecting the equivalence statement. So if this buffer zone, if it's 1 minute, so that this buffer zone is 29 to 31 minutes, then we still claim that they're not equivalent. The average delivery time is not equivalent to 30, or it's not equal to 30, but we still reject, but we still could not reject the null hypothesis that the mean delivery time is 30. So note the difference. And what's the takeaway? It's that when we do not reject a null hypothesis, we cannot establish an equivalence, because those two are different. Statistical difference is not just the opposite as a statistical equivalence. There's also some zone that they do not overlap. But that's sort of beyond the course already. We don't have to go that far before answering all these questions. All right. Did you have any question regarding part B? Oh,
I think we're ready for number 3.
We already discussed that, right? Okay. Yeah. So we could do the same for 99% confidence interval corresponding to 1% significance level. I think I made some notes on this. It's here, so I encourage you to read them. It's somewhat a lengthy paragraph. It gives the information about more about how a p-value is corresponding to a confidence interval. All right, how about problem 3? Any questions here? Here we are testing about regression coefficients.
Yeah, I have a lot of questions. There's the
really?
first
Okay.
one that sticks out is the quantity of stores, or the quantity of data points is 15, and I know that's lower than that CLT theorem. The direction I'm kind of thinking is that we're testing that there's no correlation, so like the slope is 0 versus not 0. But I don't know how you get a population mean and kind of work through some of the numbers.
Oh, I see. Okay. My understanding is that you were not sure what reference population mean we need to use to make the test statistic, right?
Yes.
Okay. Did you also have questions regarding what degree of freedom we should use?
No, I got that. That's fine.
Oh, okay, beautiful. Because it could also be a source of confusion. All right. Anyway, first we need to build the regression model. So we predict the sales using advertising expense. We have built this many times, so that you should be all very familiar with all of the regression procedures. We select sales as Y and advertising as X. Oh, any question there? There was a label, and we do want a constant. That's the intercept. We do not select constant is 0. Then I would put the output right, well, beneath it. All right. Then I have the output of the regression model. I believe most of you should have exactly the same thing as what I have here. From this, I can safely and confidently say that for each dollar additionally spent in advertising, the sales would increase on average by $3.78. All right, let's see what we need to do in the hypothesis testing questions. Is there a significant relationship between money spent on advertising and sales? Test at 5% level of significance and explain your approach. So could the student repeat what questions you had here? Was that you were not sure how the t-statistic is calculated?
Yeah, a little bit. I'm just kind of the approach I'm taking is obviously if you want to test if there's a relationship, if there's the null hypothesis should be that the slope is 0, if I'm understanding this, and then
oh yes,
the
you're right
alternative
on that.
hypothesis, yeah, the alternative is that it's not 0. But because it's less than 30, you would use a t statistic. But I'm kind of not understanding how we're like the population or the sample standard deviation. How are those things calculated?
Oh,
or
okay.
are those even needed?
I see. Yes, they are needed. And here, in this case, to test coefficients, we always use t-statistic. The reason is it's not because of the sample size. Even if we had a sample size like 10,000, we still calculate a t-statistic. The reason is we do not know the true error in the model. So here, the error term is estimated after we build the model. So we do not know the error term at all, right? The true values of the error term. That's why we say that we do not know the sigma. So we use sigma unknown case. Then it corresponds to t-statistics. Any questions there?
So you're saying you would just leave it blank?
Blank? No. I'm saying that we need to calculate a t-statistic, not because of the sample size as 15 stores. Even if we have, let's say, 10,000 stores of data, we still calculate a t-statistic and use a t-distribution because we do not know the error term. So with that, we calculate a t-statistic out of it. This is actually conveniently given here as the t-statistic. So we could use that. And with that, if the null hypothesis, if the H0 is, B1 is 0, then of course the alternative hypothesis would be that this coefficient is not 0. This is exactly what these testing statistic and the confidence intervals reports. It corresponds to a null hypothesis saying that the coefficients, including the intercept, whether it's 0 as the null hypothesis. It does not test anything else, but only this hypothesis. Was there a question?
Yeah, for row 37, could you just say that in English one more time?
Rule 37?
Yeah, your Excel.
Rule 37.
Yeah, could you just more slowly go over what you just said?
Okay.
Thank you.
So what I'm saying here is what's written or given in these columns as a t statistic, p-value, lower and upper confidence interval. Oh, okay. I don't know why it's given twice. And these t, p, and confidence interval corresponds to a hypothesis like what I wrote here. They're testing about whether each of these coefficients is equal to 0 as the null hypothesis. And with that, the alternative hypothesis is simply whether each of these coefficients is different from 0. Any questions on that?
I think so. It's making sense, Trey. I think what we're kind of saying is we get that it's null if we reject it. Sorry, because there is a correlation. And I think I'm personally struggling with how we describe that in the answer. Is it because our lower confidence and upper confidence levels, our advertising is 3.7 cents between those levels, or is it because the t-stat isn't 0? I think that's where we're trying to draw the conclusion.
All right. So how do
and
we
if I could
draw a
add to that
conclusion
real
out of it,
quick,
right?
what's the best statistic to look at to answer this question? There's a lot of choices here.
Yes, you're right. There are a few that we could use. They are equivalent, as we practiced just now about the relationship between confidence interval and p-value.
Can I share how I answered this? I used the p-value, and because it's virtually 0, and I said that p-value then tells us that there's no way we can be wrong when we say there's a relationship between sales and amount of advertising by rejecting the opposite.
Rejecting the opposite. Okay. Well, so I think it sounds okay, but I was not so clear what opposite means in this case. Well, how about I practice this part, then we can see what statistics we can use to answer this question.
That would be helpful. Thank you.
Yeah, as we practiced in the previous question, we could use either a p-value or a critical t-value or the confidence interval to answer these questions about hypothesis testing. So let's use each of them and see which of them is your favorite. If we use the t-value, we would have to calculate a critical t-value in this case. This critical t-value would have to be built from this sheet in the sigma unknown case, because the sigma known case is calculating a z-value instead to use a normal distribution. But because in regression, we never know the error term. That's why we always use the t-distribution. And let's see how we can build the critical value out of a regression model. We first would need to use the degree of freedom in the total as the as the sample size -1. Or let's see whether there's a smarter case. Okay, I think here it might be better. We use this confidence interval for population mean and the sigma unknown case, so we could also find the critical t-value. Then compared to the null hypothesis, we don't need the reference mean at all. Yeah, either of these should work. So if we are testing whether the coefficient is equal to 0 or not, right? So we put the reference population mean as a 0. The significance level, let me make sure, because here we are testing at the 5%. So we calculate, we input the significance level as 1/20. Sample mean would be the estimated advertising coefficient. So we transform the sample mean here. And the sample standard deviation would be, well, some form of this standard error. Note that the standard error is already scaled to be divided by the square root of the sample size. So we could do this. We copy and paste the standard error to the standard deviation part and claim the sample size as 1. Oh my God. Okay, it doesn't do it. Let's see. Or I calculate this sample standard deviation as the standard error times square root of the sample size. And in this case, our sample size is 15. And sample size is 15. All right. This would be the critical value of t we use. Could you tell me which of these 3 columns you're going to use to answer this question?
Your values are not there.
Right-tailed one.
All right. We use the 2-tailed one, but let me just make sure whether the sample size is 15. I don't believe so. Let's see. We are doing a 2-tailed test. That's true. And this t distribution should have 13 degrees of freedom. So the sample size might be 14. I think, yeah, we will have to do this. Yeah, unfortunately, this is more unstraightforward. There are many, steps we have to, we would have to customize the
Jerry, I
case.
think
That's why
yeah, there you go.
it might be better to use other statistics that's more conveniently given. How about we try the p-value? If we take the p-value that's already calculated here, we know that this is smaller than 0.05, right? That's the significance level. So we would claim we reject the null hypothesis. But note what's the null hypothesis? That the null hypothesis in our case is that the coefficient is equal to 0. So we reject the hypothesis that the coefficient is 0, so that we know the coefficient is not 0. That means there's a significant relationship between advertising expense and sales value. Any questions there?
And if I may ask, is that relationship, is that determination the only thing that can come from this regression? Is that the relationship between one or another, with the independent to the dependent? Is that what this kind of tells you? Otherwise, you would have to move to a full hypothesis test. Is that kind of the unspoken thing here? Is that the only the point of this p-value? Right. Is it okay.
Yeah, you're right.
That makes sense now that you're explaining
here. Here, once we reject the null hypothesis that the coefficient of advertising is 0, we're saying that the coefficient is different from 0, right? but we did not put a sign on it whether this coefficient is greater than 0 or smaller than 0. So to make a substantive conclusion or qualitative statement, we would say that simply there's a statistically significant relationship between money spent on advertising and sales. However, if you want to put a sign on it saying that there's a positive relationship between them or a negative relationship between them, this p-value actually does not directly address that question at all. We would have to double the p-value to calculate. Let's see, do I double the p-value? No, we let's see. Yes, we will have to double the p-value to answer a question regarding a signed or one-tailed case. So we can see it conveniently here. Well, maybe I can go, well. We find that this two-tailed p-value is simply 2 times of this one-tailed p-value. So note here that this e minus 0.5 is simply saying that it's 10 raised by the negative 5 power. So we can ignore that part, but focus on the front. Here we have the two-tailed p-value as 2.07, right? Whereas the right-tailed, that's one-tailed p-value, is 1.03. We find that this two-tailed p-value is exactly 2 times the one-tailed value.
Jerry, can you please repeat where you got the 2.18251?
Oh, how I got this p-value?
No, in your sample standard deviation.
This one?
Yeah.
Is calculated as the standard error.
Got it. I found it. Thank you.
Already given, but we have to times the square root of sample size to resume it back to standard deviation of the original values in the sample. Because here, yeah, it's standard error. That's the standard deviation of the mean value. So we have to transform back.
Thank you.
Yeah, but as you can see, to calculate the t statistic is somewhat, well, difficult. Okay, but
Jerry, just to confirm, what's the null hypothesis in this case?
What's the null hypothesis in this case?
Yes.
Oh, yeah.
Problem number 3A.
I wrote it here. The null hypothesis, the coefficient is equal to 0. But this t statistic, you don't, well, if you don't use these sheets, it could be calculated more conveniently. It is simply that we calculate the t statistic as this coefficient minus 0, because we are testing about the reference mean value to be 0, right? Divided by the standard error, so that we don't have to, change or alter anything. So this is the t statistic. It equals to this one. But we can calculate the reference t critical value. It'll be a t value that has a degree of freedom as 13. So we would have to use this one. And to find that, we should have a sheet of critical values, right? Yes, that's convenient. We would put the cumulative probability as the remainder of the significance level. Degree of freedom, all right, we put 13 here. Then this would be the corresponding t value of the critical value. As it shows here, it'll be this value.
Jerry, I do not understand why we cannot solve problem number 3A just through the regression model.
We could, but
could, right?
yeah, I was showing
Using the
that
p-value.
you could calculate such statistics in many different ways,
Okay.
and
So we
it
can
really
just-
gives you equivalent
we can-
answers. Yeah,
We can just say that the null hypothesis that there is no relationship, and then we reject it based on the p-value that it's 0, right? This p-value is 0.
it's not 0. It's p-value can never be 0. It'll be above 0. It'll be between 0 and 1.
Right, but it's like
It's
really
very close
to
to 0. That's true.
Correct.
Because this p-value is smaller than the significance level, then we reject the null hypothesis. And
That
note
there is
here,
no
null
relationship.
hypothesis is no relationship, or the
Good.
coefficient is 0.
So we don't need any of the math. That's the other one. We
Mhm.
can solve it through this regression model.
Yeah.
Just wanted to confirm. Perfect, thanks.
We could also answer the question by confidence interval. And to do that, we simply compare whether this confidence interval includes 0. We note that here the confidence interval is conveniently laid out. It says the confidence interval for the coefficient is between these two values. And you know that 0 is not in between these, right? So we could also reject the null hypothesis because the confidence interval does not include a 0 in it. Well, was there a different way to address this question? I think this is probably all of these approaches we could use to address this question. How about the other two? I think they should be very similar. Ooh, okay.
Yeah, I think Jerry, thank you, by the way. I think, yeah, A's taken care of well. I think I'm struggling to translate what we just did into on the question B, and I think I just need a little help getting there, and I can do the math, but we have our numbers. Yeah, now we're talking about adding $1,000 and the impact that would have to the sales. And like, I know that's not true, but I don't know how to convert that into our statistics file.
All right. It's actually, it may not be as complicated as you thought. It's supposed to be a simple practice. Here, to address a question regarding some added value in the advertisement, it's nothing but a slightly altered version about the coefficient. Note here, for every dollar you used in advertising, there's an increase in the sales, right? So we simply use this case and this fact, and also the relationship and the coefficient we just calculated to answer this question. And okay, we test the claim more than 2. Okay, this is assigned directional hypothesis testing, so that we have to use the one-tailed tests. And to do that, I would say that the best option is to calculate the t-value associated with it, and also the critical t-value, so that we have a comparison. Then we determine which of them is greater.
That's a right tail?
Okay, let me make sure.
Well, just to clarify, is this question asked for that?
Claim. Yeah, it has to be a tailed test, and I'm making sure whether it's right-tailed or left-tailed.
But isn't it just saying if you come up with more than $1,000, can't you just look at the simplest way to solve this with the confidence intervals?
No, because the confidence interval, as I just claimed earlier, is built regarding whether the advertisement is equal to 0. This confidence interval does not answer questions regarding a directional hypothesis testing.
Jerry, I do not understand. This is Adam speaking. Why we cannot use this same exact regression model to answer that question, since every 3.7 and advertising would increase sales by $1, we can answer that part B through this equation or like through this relationship, right?
Nope. The
Why not?
reason is here, if we simply use this coefficient without using without doing any hypothesis testing, it won't. It involves a sampling error, so that we have to use a hypothesis testing to answer questions regarding population questions. Do you
So
see
we
that?
use
So
3%
let me
answer that
rephrase
question.
what I just said. The reason why we are doing all these testing is that the true population parameter, in this case, the true coefficient, may not be exactly as estimated. It might be a slightly different or even dramatically different value. Although in our model, we estimated that the coefficient is, this value to be almost 4. At the same time, the true relationship that we do not, directly observe, right? Since we have only 15 stores. If we manage thousands of stores, the population coefficient could be different than this value. That's why we need to do a hypothesis testing involving sampling errors to infer about the population coefficient.
So you just mentioned the key, the population size is too small at 15 observations. Is that really what the crux of this is? Why we can't rely on regression?
Yeah, you could say that. However, note that even if when this number of stores could be, thousands or even millions, you would still need to do hypothesis testing to address a question regarding population parameter from a sample.
So how would you solve this one?
All right, great. Let's see. We do it by calculating the t statistic critical value. We already given the t statistic value here, right? So we only need to find the critical value of t. And let me see. Oh, we also need to somewhat recalculate the t again. Okay. Let's build on part B. So we calculate the t as the coefficient minus the reference. The reference here is whether it's greater than 2, right? So we give 2 here. Then we divide it by the standard error of t. It's already calculated here. So this would be the observed t-value. Note that this t-value is different than the t-value given here because they are answering different questions. What's given in the regression table is answering a question like whether the coefficient is equal to 1. But here, we are answering the question as whether this coefficient is smaller or equal to 2 as the null hypothesis, and coefficient greater than 2 as the alternative hypothesis. Because when we reject the null hypothesis, we want to find a significant difference, right? So if we are testing whether it's greater than 2, then it's as if saying whether we have evidence supporting this claim. Okay, that's why we would form the null and alternative hypothesis in this particular way. If we find evidence about this claim, then it will go here, so that we build the null hypothesis to the opposite of it. All right, given the observed t, we simply find the critical t. Critical t can be found through this critical value sheet, and we simply need to make sure what degree of freedom should be used. as I announced earlier, we have to use the degree of freedom in an ANOVA table in the residue row. This is because if we have 15 observations and 2 parameters to estimate, we will take 15 minus 2, that would be 13. And if we put 13 here, let's see. In this case, we have 0.95 as the cumulative probability. That would be 1 minus the significance level. Then we get the corresponding t value as the critical value. Then we compare these two values. Copy and paste. Because the calculated t above is greater than this critical t value, we say that we reject the null hypothesis. So we find significant evidence that the coefficient is greater than 2. Any questions here?
Yeah. How did you get to that 3.156 again?
Let me show the formula. It's simply calculated from the regression table as the coefficient minus 2, because here we transform the question as from this state claim to be whether the coefficient is greater than 2, right? So that's why we use 2 as the reference coefficient and divide that by the standard error of the coefficient. So it forms a t statistic.
We're comparing the 177 to the new T you created, or?
Yeah, if this T is greater than the critical one, then we will say it's we reject it. Otherwise, not. Well, so here I was considering whether this critical T needs to be altered slightly because we are doing a tailed test. So this cumulative probability might need to be 97.5%. Let me see whether it makes any difference. Well, first, it won't make a difference in terms of whether we reject or not reject. Oh, I see. Okay. I think because the original question was already formed as a signed question, and it's 5% level of significance, so we don't have to transform it further. Then this critical value built from 5% as the significance level and the 13 as the degree of freedom should be directly useful. Because the original question is already a directional testing. All right, how about part C? Have you done that? And any questions?
Did we decide that's a right tail or if it's a right tail test?
Oh, I see. That's a good question. Here, we don't have to concern about that anymore because it's already transformed in that way.
Gary, for 1B, so we can support the claim that every additional $1,000 in advertising increases sales by more than 2,000, correct?
Yeah, because we reject the null hypothesis, and it means we have a significant evidence that the coefficient is greater than 2. That means for every $1 we spend on advertisement, there will be more than $2 earned back.
Oh, thank you.
All right. How about part C? Have you done that already? Find 95% confidence interval for the change. Oh, okay, that's why. In sales, given 1,000, say 1,000 increase in the amount of money spent on the advertisement. Okay, any thoughts on that?
Sorry, what was C? Are you going on D?
Oh, was there a D? I don't think so. There's only 3 parts, unless you give yourself a bonus question. Yeah. So part C in problem 3 is about a confidence interval of a change. Any thoughts on how you addressed it or how you plan to do it?
Not anymore. Afraid not, Jerry. I need a little help with this one.
Oh, I see. It seems it might be particularly challenging. How about other students? Any thoughts on how you might want to address this question? How you can find a confidence interval for a change?
Well, we could calculate the confidence interval when we ran the regression, correct?
Yeah, you could do that. So let me give you a hint.
But Jerry, isn't this given in the Excel which we calculated it?
Yeah, we do need to make some calculation, but most of the information is already given. So my hint is that how we measure the change. We measure the change by the effect of the sales, by the effect of the advertisement spending on sales, right? And this effect is measured by the coefficient. So this question is nothing but a transformation about the coefficient. How do we get the coefficient to answer a question regarding about 1,000 increase in amount of advertisement spending? We simply times the coefficient of advertisement spending by 1,000 because the coefficient measures nothing but the increase in the amount of sales by one additional dollar spent in advertising, right? So if we times that by 1,000, it will directly answer how much additional sales we would get by spending 1,000 additional dollars in advertisements.
That's great. Thank you.
Yeah, so we're literally, Jerry, it's as simple as that, where we would now spend $3,778, or we would see a $3,778 increase.
Yeah, so this increase would be the coefficient times 1,000. This is the increase, right? Now we need to find a confidence interval about it. Well, this is actually conveniently given already. It's calculated here. So if we build a linear transformation about the confidence interval, it'll be just a linear transformation. So because we got the coefficient as the coefficient times 1,000, we do the same thing for the confidence interval. So it'll be this times 1,000. Well, times 1,000. Then we do that again for the other limit. So this would directly answer a question. If I spend $1,000, how much more additional I could get in sales? And this coefficient times 1,000 gives us a point estimate, whereas the upper and the lower limits of the original coefficient times 1,000 would give us a confidence interval. Any questions here?
Oh, that makes sense.
All right.
But it's not asking for the new confidence intervals, right? You're just giving those to us.
But it is asking for how to find the 95% confidence interval.
Yeah. If you want to calculate these confidence intervals yourself, you could definitely do it by going back to the t-value and find a confidence interval from not hypothesis testing, confidence interval tab. So for example, I could do one demonstration, so you could repeat the case in many more cases. Okay, confidence interval. We have to supply sample mean, sample standard deviation, sample size, and a confidence level. So if we want to retrieve this confidence interval, we would have to use this coefficient as the sample mean. Oh my God. Copy and paste. Sample standard deviation would be this value times square root of okay, well, now I need to pay particular note caution here because it does matter. Sample size, I think, let's see, sample size. Oh, I see. It will be either square root of 15 or 13. I guess I would have to try both of them to find which one to use. Let's see whether I got the same answer. It should be at least very close. This would be 2.45 to 5.09. It's not exactly the same, but it's very close. If I fix the sample size and the standard deviation formula, I should retrieve exactly the same thing as given here.
Jerry, so is it wrong then if we don't multiply the lower and upper 95% by 1,000 and just say the range is, 2.56 and 4.99 or 5.0? Would that be an incorrect answer?
Yeah, it will be incorrect because here what the confidence interval is for the change given this much. It's not a change given $1 increase.
Okay, thank you.
Yeah, so you could rebuild the entire table from some of the given statistics, but it'll be slightly difficult to calculate these. So in those cases, it'll be better to use whatever it's already calculated here. And to answer a question like whether the coefficient is smaller than 2 or greater than 2, we use what's already calculated as the standard error and the coefficient. To answer a question regarding the confidence interval about a change, use the confidence interval that's already given and understand what and try to find the relationship between the required change and the estimated coefficients, so that the calculated confidence interval will be transformed to another version that corresponding to the one required in the question. Oh my God, I didn't notice it's already too many more minutes than necessary, but I hope you find the review session useful. I encourage you to read the remaining part in the notes. It gives more about what procedures we need to give. So from here, you could find those particular procedures that first guarantees that you derive the correct decision from the correct logic. And also there's additional reading material you can use to understand how this p-value is calculated and how it's related to confidence intervals.
Awesome. Thanks for all the work, Jerry.
All right.
Thank you, Jerry.
Yeah, thank you very much.
Thank you very much, Jerry. That was
Nice
awesome.
meeting you too. Well, don't
Thank you,
forget
Jerry.
to fill out the feedback form. I
Gotcha.
listed the link in the shared notes. You can find it again in the announcement in the Canvas tab.
All right, thank you very much.
Thank you,
Bye.
Jerry.
Thanks, Jerry.